Hi, welcome to Module 6. This is Part 2. We're going to talk about solar ovens. Solar ovens work on three basic concepts: concentrating sunlight into the device itself, converting that light to heat, and trapping that heat so that we can continue to build on the heat that's currently there within a little thermal greenhouse, right? We're creating a greenhouse effect within our trappings. We can do solar ovens out of anything. We can make it out of a flower pot. We can do it with plastic bags. If you haven't ever opened up a hot garbage bag in the sun, it is a stinking hot mess, right? So this is something that's a very easy build, but it can answer so many problems. And once again, it's a passive system. I'm not making electricity with that system. I'm just utilizing what is currently in place to take advantage and do what I need. Now, this is not a fast process. This is something I have personal experience with. I've utilized a solar oven, and especially when I was in grad school, and I remember we used to buy those Annie's burritos. We had the solar oven, and it's actually in one of these pictures. Let's see, right there. And we would stick those, we would unwrap them, and we'd stick them in here before we go to class. And then when we got back from class, our snack was ready, right? So this would be a little trick. And right here, you can see we're making a corn muffin in the solar oven. So popping back, this one, once again, we can see the concentrating sunlight into the system by using these mirrors or reflective surfacing, right? I'm trapping my heat within my system. And then within there, you can actually see these are like a painted black box. You can see this is an insulated black box. We are creating a system where we are converting any sunlight that's in the box into heat. So I'm using a thermal capacity. Here's a reflector system, sun-tea style. If you remember back in elementary school where you'd look at diffusion by taking a container of water that has a clear pot and you put the tea bags in, you bring it outside and you watch it diffuse as it heats up, right? So we're creating a little reflector. Here's another really simple, just using reflectors to create a solar oven system where I can cook. Here's a box type. This is the pizza box style type. And then once again, this is the one we have at the McCoskey Center. This one was very serious. We were using it to cook food that we required to eat. So this was very purposefully built. Once again, both of those systems that we just talked about is passive solar. Now we're going to talk about passive solar in a home. So orienting and arranging and using things in your home to create thermal capacity so that we can convert that light to heat to take advantage of what we need. Passive solar homes that are built can save as much as 50% on heating costs, and that is a 1 to 5% increase in construction cost overall. Can do this simple maneuvering. Now I know we live in an area in Valhalla where we are retrofitting homes. We are not taking something that is a new build. So we don't necessarily have the passive solar capacity in the home that's currently built. But that doesn't mean that we can't do things within the home, remodeling style, to take advantage of solar capacity within. Here is the picture in the book that's showing us a high performance home with lots of windows. If this is in the northern hemisphere, we know that these windows would be south facing, right, to take advantage. And then once again, you can see the tiling on the floor. The tiling is important because these tiles will have a better ability to conduct the heat energy. So it's going to be absorbing that sunlight. And then in the evening, when the sun goes down, I'm going to want to close the drapes to keep this area warm and allow those tiles to share the heat energy that it's been absorbing all day long with the rest of the room. This is a picture that's showing a home that was built in a passive solar style inside the town of Concord, New Hampshire. And it's showing you that inside the home, its ability for capacity of heat, and outside what the temperatures were at a given time. So over the course of the day of January 25th to 26th, we can see that it was pretty warm in the afternoon, and we can see that the home just begins to heat up, right? And then it's holding on to that thermal capacity throughout the evening, because here's midnight, right? And then by noon the next day again, we can see that it kind of maintained its curve of heat at a certain baseline. right? So there's an ability for these homes to maintain heat within themselves. This is a concept called a Trumby wall. Trumby walls are using a structure that's not blocking the window itself, but it's up near the window where there might be some footage of space between the window and the wall that allows us to absorb sunlight up into the actual structure. And so we can use different things with thermal capacity. They could be concrete, they could be structures that are made out of stone or some type of tiling. There's art pieces, and now we've even seen Trumby walls that are fluid. They're called fluid Trumby walls, and they're using capacity of these water tanks that are very attractive. Now think of a big building, like a standard commercial building structure where you have windows that are just pouring all the sunlight in, and it's such a pain. And so what do? We put up blinds to try to block out the sunlight. Instead of that, let's take advantage, reduce the heating that's necessary for the building, and put Trumby walls in to the structure and allow us to just absorb that sunlight. I mean, for the most part, somebody closes the blinds and they don't get opened again for months and months and months. So, take advantage of the system that's there, and you can do something very sustainable with the capacity that's present. So here's some example of Trumby walls. Once again, it's not blocking the window itself, but it's very close to the window. And so here's some Trumby walls, right? And this is in an office style construction where you do not want the sunlight really in the building because it's just creating too much glare. This one is a Trumby wall that's quite purposely built to be attractive, and so you can see that the windows go all the way down, but the wall is here as a little walling structure within the home. And here is that fluid Trumby wall that I was talking about where they're using water tank style, and that's very attractive, right? So there's a measure to be made, a sustainable practice that's being built on that one can take advantage of, and ways that you can experiment and be quite creative within a space. Talking about old systems of using energy, one of the early uses of creating hot water is these structures where we actually heated water. And the Egyptians were doing it, and then the Romans also picked up on it with bath structures. And some places didn't have the ability to find a hot spring, right? So they didn't have a hot spring available. Instead, they created warm water by creating these troughs that they then put metal tubing within, and the metal tubing and the trough absorb the heat, and they actually would disperse it into the water as it trickled past. So that's one way to heat up your water. Looking at a passive solar home design, this home was built to be passive solar, and this is actually a place called Terra Day. It's in Prospect, Pennsylvania. And this structure is built so that there is a window set along the top, like an extended greenhouse on the structure itself. And inside is the flooring that has thermal capacity. There are windows in between. And even though this room is an indoor room, right? This isn't a greenhouse. This is an indoor room in the structure. There are windows so that if it's really cold and I'm not getting good thermal capacity, I've had a lot of days of cold weather, I can shut out the room. Also in the summer, when I do not want to share the heat that's building up in this room, I can shade out the room, close up the room, open up the windows, but then close out the house and shade out the house. And so this little extended room is acting as almost like a little attached radiator, taking advantage of the sunlight within itself. Now, if the weather is really good and I want to take advantage of the heat and it's winter and this room is nice and warm, I then open up all my windows and doors in my little structure over here, and I let all the heat into the house. And this is an example of what this would look like. Now, this house would have a lot of open cathedral sets within it, or little jump rooms, or areas that have overhanging lips, little princess balconies in other parts of the house to allow the heat exchange through the building. And then the other key part about the building is that there's somewhere for the heat to escape in the roof, because the warm air will be less dense. It'll be at the top of the surface, and so I will have some place for heat to escape. So on that note, we'll talk a little bit about passive solar home design buildings, and then we'll start talking about how to make a passive solar shower.